So we'll get started. So I wanted to start by saying that both NLU and Platt were developed based on regulatory requirements. And I'll give you the history of NLU. Platt was developed because the 590 standards said that everyone that applied animal waste had to use either a phosphorus assessment, a soil test cutoff level, or a soil threshold cutoff level. And North Carolina, along with 47 other states, decided to do a phosphorus assessment. And every state, for the most part, developed their own phosphorus assessments. So I'm going to go back and start with NLU, though, because it was the first tool that was developed. So can you see my presentation
Yes.
PowerPoint? Okay.
Yes.
So we're going to start by talking about nitrogen loss estimation worksheet. I apologize that I didn't realize I was supposed to do Platt too, but I can talk you through Platt. So I want to discuss two things. I want to talk about why we developed Platt and then discuss the tool. And people have thought from time to time that that NLU was just a paper exercise, but I would say that it's not just a paper exercise. And I want to first of all talk about the development. So under the NUS rules, and then the TARPAM, and then the Jordan, and then the Falls, farmers either had to use individual conservation practices, which included either a 50-foot riparian buffer or nutrient management and this other buffer or nutrient management and controlled drainage, or they could be part of the local option. Now, that's why we go through the local option exercise every year, because you can imagine how much money and time it would take for every single farmer in all of these watersheds to implement these conservation practices. One of the things about NUS is that because the individual option does not have to be used, they were the basin could develop these local area plans. And it was really important for local control. And they had to be part of the local option. They had to be accountable for nitrogen reduction. And most importantly, this is why NLU was so important. A tracking tool had to be developed to account for nitrogen reduction and determine the nitrogen percent reduction for each local area, determine the nitrogen losses from baseline, track changes, and look at, this is really important, conservation effects over these time periods. So there were really specific guidelines that were written into all of the basin rules for this tracking tool. And so now I want to talk about the development of the tracking tool, because this tracking tool, along with Platt, is what you guys use in NCANAT to look at pounds of nitrogen reduction loss based on your conservation efforts, or pounds of phosphorus per acre reduction, again, based on conservation efforts. So, oh, and let me just say, if you guys have any questions while I'm going through this, either just cut me off directly or put it into chat, Allie, and you can let me know, because I can't see any of you at this point. So we formed this multi-agency team with all of these different groups. That's really important. And at the time that we started, NRCS had taken the lead, but they were totally focused on reducing erosion. The problem with that is that most of nitrogen loss that we see from our agricultural fields is nitrate nitrogen moving through the soil into the shallow groundwater and then into the streams. So we really needed to focus on a soluble form of nitrogen, not soil erosion. And then we had to decide what BMPs would be effective and how effective those BMPs were. These are the committees that made up the NLU team. First of all, there are some differences in the structure of our agencies these days than when we started. I would say that if you look at these people, only Rich Gannon and myself remain working. So I want to be really clear about what it is and what it isn't. It's a tool for tracking BMPs and accounting for nitrogen reduction. It deals with soluble nitrogen. It's biophysical. We knew where our data strengths were and where our weaknesses were, and we assume it's at steady state. This is not an agricultural water quality predictive nitrogen loss model. You do not want to look at agricultural water quality predictive nitrogen loss models for a whole lot of reasons. I've been working with models for over 30 years, and they are super difficult. They need to be calibrated. They need to be validated. You need lots of water quality data. And I'll tell you, you do not have time or resources to do that. And so I just want to talk a little bit about, oh, I'm sorry, let me go back to this slide. It doesn't deal directly with soil organic matter mineralization. It doesn't deal with nitrogen denitrification, and we're not dealing with a black box. And I want to talk about why we're not dealing with soil organic matter mineralization. These are some data from an experiment that a graduate student of mine did. It has coastal plain data, it has Piedmont data, it has mountains data. We ran the experiment 2 different years, and we measured the amount of what we call apparent nitrogen. That's the amount of nitrogen that's taken up by the corn when you don't apply any nitrogen. And the thing that's really interesting is that, for instance, the Piedmont fields were exactly the same soil map unit, and yet one year, one field had half the amount of nitrogen that was released from soil organic matter as the other field. Soil organic matter nitrogen release is highly, highly dynamic, and there's really no way to capture it. And that's why we stayed away from it. We also know from work that's been done that there's a certain amount of nitrogen that leaves the root system, goes into the shallow groundwater. These were estimates, well, they weren't estimates, they were based on data that wasn't published. This shows that anywhere between 1 to 40 pounds of nitrogen, and you can think of this as pounds of nitrogen per acre. It's basically the same thing. Upwards of 40 pounds are lost per year. So a lot of nitrogen leaves our agricultural fields. And so for NLU, we wanted a field-based, user-friendly program that didn't need a ton of data, that could be used across the state of North Carolina, and that had relative effects of nitrogen cycling. We also wanted to make sure it was something the farmers could control. That's super important, because if you go to a hydrologic model, the big factor in hydrologic model is the amount of water that you receive every year. Farmers have no control over that. So what they do have control over is how they manage their nitrogen. And I'm going to go through this real quick, but these are the factors that you need to run NLU. You need to know the soil map unit. So you take a field and you figure out the predominant soil map unit. You need to know the crop, and of course you would know the crop. You need to know how much nitrogen is being applied by the producer, and then you need to know which BMPs are being used, including if cereal cover crops are being used. If you have any questions about this as I go through, ask me now, slide by slide, because this is basically how it works. You put in the soil map unit, and I think a lot of you have probably worked with NCANAT, so you know what the soil map unit is. In North Carolina, we have realistic nitrogen rate applications based on soil map units. This was an exercise that was done, again, by a whole group of interagency people. We know how much nitrogen should be applied. And that's really important, because one of the most important conservation practices you all use is nutrient management. And so we want to make sure that everybody's applying the right amount of nitrogen. And we've confirmed our realistic yield expectation nitrogen rates through a number of different experiments over the last 20 or 30 years. So you know how much nitrogen, and the amount of nitrogen that you need to apply is in a database. So if you say what the soil group is, the program automatically knows what the realistic yield nitrogen rate is. And just here's a table of it. And for instance, corn grain on a Lloyd clay loam, so that's a Piedmont soil in Rowan County, requires 131 pounds of nitrogen. This is really important because, again, anything above that is doesn't adhere to nutrient management. So the way the program works is that you put your current nitrogen rate in. The program already knows what the nitrogen rate should be, and then it partitions the nitrogen. And if you only put on enough nitrogen for the realistic yield nitrogen rate, then it all goes into the realistic yield, or the RYE nitrogen box. That's on your right-hand side. If you put more nitrogen on than you should, then that additional nitrogen goes into excess nitrogen. So let's say the farmer's on this Lloyd, instead of putting on 131 pounds, he or she put on 151 pounds. So there'd be 20 pounds of excess nitrogen going into the excess nitrogen pool. Okay, so that amount of nitrogen that should be applied to the crop is not taken up 100% by the crop. There's always some inefficiency there. So the next thing we had to do as committee is go through the literature to figure out what percentage of the nitrogen does the crop take up, not just for the grain, but for the entire vegetative and reproductive structure. And this is going to change based on a lot of different factors. So for instance, Bermuda grass, based on the literature, has a 75% effectiveness uptake. So it means that it takes up 75%, there'll be 25% remaining. And you can see that for corn and soybeans and sweet potatoes, etc., based on the literature, we knew how much nitrogen was being taken up. If you average these, basically overall, about 50% of nitrogen is absorbed by the crop. That means you have 50% that can be lost to the environment. So the crop takes up the 50%, and then there's this subsurface nitrogen that's left. So about 50% would be left. For the excess nitrogen, there's no hope that the crop's going to take that up. And so some of that will be lost in subsurface and some will be lost in surface losses. I said earlier that 95% of the nitrogen is soluble and it's lost through the soil system into the shallow groundwater, but that leaves 5% remaining. And so you take these subsurface flows of nitrogen and then you apply conservation practices to them. And so I want to talk about the conservation practices that we looked at and their effectiveness value. So we went through initially, and Wendell Gilliam was at that point the person working with riparian buffers. And these were the effectiveness values that he gave. And let me tell you that they're pretty much wrong. And I'll tell you why they're wrong and what we did to change them. The water control structure data, we had very solid data for, and it's remained in place. And we gave 5% reduction of nitrogen to stream bank stabilization. But let me just tell you that was kind of a guess, and it never ended up being programmed into NLU because we just had so much uncertainty around that. So we did some experiments. They were 12 years long. We looked at different vegetative types. We looked at different buffer widths. And the committee came up with the fact that, let's say you have a 50-foot riparian buffer, you get about 50% nitrogen reduction credit. And we didn't go lower than 20 feet because there was no conservation standard that would let us go below 20 feet. I think for a vegetative buffer, 20 feet is the minimum standard. So we reduced the riparian buffer credit, nitrogen credit, based on much more credible data that we had than the data that was originally programmed into NLU. And so let me just say that at that point, we still had subsurface losses from the BMPs because, again, they're not even 100% effective. And we decided that there could be an additional reduction based on cereal cover crop. And the amount that we gave cereal cover crop, we used data from Michael Wager. These aren't as solid as I would prefer, but they were all that we had at the time. And cereal cover crop got approximately a 10% reduction credit. So this ends up being the estimated nitrogen leaving the target area. And so if you're using NLU in the NCANAT program and you want to compare your situation and then what's been done after conservation practices are implemented, then it can calculate the reduction, pounds of nitrogen reduced because of the new conservation practices that you have on the ground. So we initially programmed NLU into being a field scale program. And then all of a sudden we realized in the new space, and we had a mere 1.2 million agricultural acres, which translated into 120,000 fields. And it would have been impossible. And Allie's going, oh, thank goodness, I could never have done all that work. So we have an aggregate version of NLU where we make some assumptions and we aggregate some of the stuff together. But in NCANAT, the tool that you all use, that's a field scale version of NLU. And so we just want to say that NLU meets regulatory requirements for all of these things, particularly capturing changes in land use, percent nitrogen reduction, BMPs, and it's used on an annual basis. But the other thing that NLU did was, because it can calculate in pounds of nitrogen per acre loss, and because it has conservation practices in it, it can be used for soil and water to account for nitrogen losses based on conservation practice implementation. And again, it tracks nitrogen flows that the farmers can change. If you went to a water quality model, you would never, ever be able to see the changes that the farmers make, because it's water that drives the final information on that. Okay, so with that, I'd be happy to take questions, or if you want, I can talk a little bit about the NCANAT tool. Are there any questions?
So Deanna, I'm not seeing any questions in the chat. If anybody does have questions that wants to come off mute, you're welcome to do that. If there's no questions, then you know, we can move, you know, you can speak to anything else that you wanted to cover this morning.
I had a quick question. This is John. I had a quick question. So, like, I saw some practices there. Is there, I mean, like cover crop, field border, is there like a limited list of BMPs that you think this would apply to?
Yeah, I mean, so we went through the whole list. So part of the problem is with nitrogen, it's soluble form, right? And there's not much nitrogen lost in erosion relative to the amount of loss in the soluble form. So most of the practices that we all use for sediment and erosion control, right, they don't have much of an impact on nitrogen. And so it's basically what practices can reduce subsurface nitrogen. And so that happens to be riparian buffers, because it can cause denitrification, and also controlled drainage, because you're changing your water balance. And again, you're moving your nitrogen losses from leaching into denitrification. I mean, it's implicitly described. And so, yeah, there aren't many practices. And as a matter of fact, conservation tillage, there are a lot of studies out there that show that conservation tillage actually increases nitrate nitrogen losses. But we didn't feel comfortable enough with that. So we give some credit to conservation tillage in the Piedmont area, because we know that under conservation tillage, the yields are better. And so we assume that there's more nitrogen being taken up by the crop. But I mean, that's a really good question. So, so let me talk about plat a little bit. So I would say that our phosphorus assessment is one of the top 3 phosphorus assessments in the country. We did a really smart thing by making it numeric. It behind the scenes, it calculates pounds of phosphorus per acre, which you guys have access through passwords. And we tried to make it super simple. You put I think you guys all know this, you put your county in, and then this is an old version of it, and you put your soil type in, and your most erosive crop. Now, one of the things about plat is that we tried to make sure that we developed it so that you had phosphorus loss from erosion, phosphorus loss from soluble sources, which means picking up plant material or picking up animal waste or picking up soil test phosphorus from the runoff that goes across the soil. Okay, so that's part of it. And then you had potentially phosphorus losses that are leaching. And you only look at phosphorus losses that are leaching in the coastal plain area on more sandy textured soils. And so the thing about tillage is that when you put in your tillage, in a way, you're thinking about what the erosion rate is going to be like. So let me speak to that in a minute. In order to run plat, you guys probably all know this, you have to run RUSLE. So John, to your point, a lot of the conservation practices are not directly in plat. And that's the thing I wanted to point out, is that they are embedded in RUSLE, where these conservation practices are going to reduce your erosion. So for instance, if you had conventional tillage, you might have a soil loss of 5 tons. But if you have conservation tillage minimum residue, when you run RUSLE, you'll only have 1 ton of loss. And then receiving slope is considered a conservation practice if it's wide enough. And then your soil test phosphorus level, I think you all know this, the higher soil test phosphorus level, the more phosphorus is going to be lost, whether it's lost through erosion processes or soluble processes. So again, when I say that nutrient management is really your first line of conservation defense, it's critically important, because if you can keep your phosphorus levels low, you're going to keep your phosphorus losses low. I don't know if I said that right. So we're just going to put 150, because that tends to be kind of like oftentimes an average. And then we're going to put 4 tons of broiler house litter. And but again, this is nutrient management practice. If you have lower amounts, if you have the amount of litter you should be applying based on nitrogen, that's great. But for phosphorus, it may be too much. And so you can choose to have a phosphorus-based plan, or you can continue with a nitrogen-based plan. And again, these are all conservation practices you need to be thinking about. And I'm pretty sure that when we calculate this, it's going to say we have we have a medium loss. So it looks like a lot of the phosphorus is coming from our animal waste. Some of it's coming from particulate P. But if we put a buffer in, let's see what happens. I haven't done this, and we're going to say it's 50 feet. And we recalculate, that's where we have our conservation practice, and we now drop it down to a low. So in plat, there are these buffer, water control structure, sediment basin, and pond are outside the practices you would use to reduce erosion. And that's why there aren't many practices, conservation practices in plat, because we're assuming most of the practices that you guys would use are being picked up through RUSLE. So do you have any questions about that? Okay, I think that's all I have, unless there are additional questions.
So there's not any questions in the chat, so I'm going to move forward with my presentation and what I had planned to cover, just with some basic background about what our ag cost share program requires, and then I have some specifics about the nutrient management software and just a little bit of background on RUSLE as well. So with that, I'll move forward, and John or Julie or Shelby, if there's any questions that come up in the chat, please let me know, because I'm not necessarily going to be looking at it. And if anybody has questions and you want to just come off mute, you're welcome to do that too. But with that, I'm just going to launch right in. So I did want to cover for folks on the line who might not be as familiar with ag cost share and all of the practices that are in the program, like what practices we calculate water quality conservation effect calculations for. So I've just done a quick spreadsheet that I'll cover in the next couple of slides, and I'm not expecting you to memorize all of these, but I just wanted to show like this suite of practices within our program that we require, these water quality calculations for. So we have things for like precision agrochemical application, and that is, we don't really use NCANAT for that. That's really a difference between like phosphorus application rates is how we quantify that. But for some of these other ones, like your conservation cover, for like field border, filter strips, those sorts of practices, we do the whole gambit. So soil saved, which is calculated through RUSLE, and then also nitrogen saved and phosphorus saved, which is calculated through NCANAT. And then just moving on, just wanted to cover all of them. So again, lots of different practices here, precision nutrient management, all the way down to some of our waste storage practices. So you can see with our waste practices, we really have more of a nitrogen and phosphorus waste managed. That's the effect calculation that is put into state contracts, as opposed to nitrogen saved or phosphorus saved. We just look at what that practice is looking at managing, as opposed to quantifying something through NCANAT with regards to those waste practices. And then again, just more of the waste practices there. Right now, I thought it was important to cover that NCANAT, like the program that Deanna shared, is no longer a standalone program. So it's been incorporated into the North Carolina Nutrient Management Planning software. And so with that component, information has to be filled in as if you're filling out a nutrient management plan or writing a nutrient management plan up to the point of entering field data before you're able to use the NCANAT tool. And the state staff's advice is for folks to be using that NCANAT that is programmed within nutrient management software, because that is the program that is most up to date. We have not been updating the NCANAT that is the standalone program since, I believe, 2015. So again, some of the previous steps up until this point, when you're able to run NCANAT, so you can see this NCANAT select option on the screen here. You do have to fill in basic background information and other information related to that, like you would be filling out a nutrient management plan. So up until that point, if you hit that select button, then you will enter into a screen that looks very similar to the screen that Deanna showed you. in that standalone program. So you would, have your county, your mapping unit is already selected because you've selected that previously along with your crop, but then you would fill in relevant data that you need to be able to complete in order to run this tool. So, the soil loss from RUSLE is put in, and then you put in, RYE application rate information here in order to calculate. And then the results are similar to the ones that Deanna showed on the screen. Deanna just ran plat, so it just showed the phosphorus rating. But in this example, NLU was run as well. And so you get a nitrogen loss estimation for that. So that is how you run NCANAT within the nutrient management software. These are all of the BMPs and the Ag Cost Share program that we calculate nitrogen and phosphorus reduction for. So not all of these practices are, not all of them are N things, and some of them might be phosphorus only, but all of these practices either have one of those nutrients calculated for it and put into state contracts. And the BMPs that we have through NCANAT are the ones that Deanna has covered, but just to reiterate, that's cover crops for species listed there, and then buffers for the various widths listed, water control structures, sediment basins and ponds are for phosphorus management only, so that's not necessarily having a impact on the nitrogen loss that's calculated through the tool, and then conservation tillage, so perennial crops, so your pasture, and then like conservation tillage or conservation tillage high residue and minimum residue, those differences are incorporated into it. So as you can see, some of these practices are very easy to walk over to these select BMPs in the NCANAT tool. Some of them are a little bit more complicated, or it might not be intuitive as to how you can calculate a nitrogen loss reduction for those practices. So like for cropland conversion, you might have to run different scenarios where you had a crop before and then you have, whatever you're converting to the field to, so like trees or pasture or something. To Deanna's point as well, with some of these practices, some of them are captured in RUSLE 2 instead of through the NCANAT tool. So I did just want to make that caveat that sometimes it's not as intuitive for the BMPs that we require conservation effects for newer staff to know how that necessarily makes the jump over to what's available for running through NCANAT. Okay, and so we have within the NCANAT program, so if we'll go back to the original slides in the presentation, nitrogen saved, phosphorus saved, soil saved, those sorts of things. So really you're comparing between what is currently happening versus what the intervention is. So we have the NCANAT compare function within nutrient management software to allow you to run those different scenarios and to estimate what the savings is. And that's what ultimately gets entered into the state contracts. And this is the approved method that we have for calculating those nutrient and sediment loss reductions for our state contracts. So with that, you write in your before conditions. So in this example, and again, these screenshots were pulled from the nutrient management user manual. So any folks that have looked at that are familiar with this, but you basically run before conditions. So in this example, it's conventional tillage, no BMP, poor hydrologic condition, and high phosphorus. The after condition is that it's the same conditions except for changing the tillage to conservation tillage and adding a 30-foot buffer. And you calculate NLU and plat for each of those different scenarios. And then you hit the compare button and it gives you a before and after, and then the reduction. So these results are what you keep for the hard copy in your record file for conservation practices. And it allows you to calculate that soil savings for contracts. So just really quickly about RUSLE 2, I'm not going to be diving into a lot of detail about it, but basically this software generates annual average soil loss results through the revised universal soil loss equation. So that's A equals R times K times LS times C times P. You can see what each of those letters in that equation stand for. So A is your result, so it's tons of soil loss per year or per acre per year. Rainfall intensity is a factor within that equation. Soil erodibility is a factor within that equation. Slope steepness and length factor is a factor within that equation as well. And really for these, for most of these three, there's not a lot of things that you can do to change it. You might be able to do terraces or some sort of practice that can interrupt steepness or that that length factor that you include in this equation, but there's really for like rainfall intensity or soil erodibility, there's not much intervention that can be done to change what those values are, but really where the conservation programs come into factoring in within this equation is the C factor, which is cover management. So you know, high residue, minimum residue, those sorts of things. And then support practices, sediment basins, other things like that, that will interrupt the flow, interrupt sheet flow through, that's calculated as part of that. So RUSLE, just for background, it estimates soil savings from reducing sheet and rill erosion. So it doesn't calculate ephemeral or classic gully. And so with that, the practices within RUSLE 2 that impact that C and P factor are really those practices that will have an impact on reducing sheet and rill erosion on a field. So results from RUSLE 2 that are typically used for the conservation planning that staff complete for federal programs, but also for some state programs or state practices include the soil loss results, which again, you plug those results into NLU and PLAT, the NCANAT tool, to generate the nutrient calculations for specific practices. And then soil conditioning index and soil tillage intensity rating, STIR values and SCI values are used you know, for making some conservation planning decisions as well. And we do have a really good background training video that Josh Spencer delivered in spring of 2021 that I also wanted to just highlight for any staff that and any partners that are wanting to get a little bit more detail about the tool and the assumptions that are within that tool that I didn't cover. That is an excellent resource to review. But I just wanted to kind of give a screenshot of what is typically run through RUSLE. So in this scenario, tobacco versus a cotton and soybean rotation. And as you can see, the results after running that through our programs and with, you know, North Carolina and your local specific soil and rainfall data, climate data, is able to generate this conservation plan soil loss, which is tons per acre per year for those different cropping rotations. So with that, again, just kind of crosswalking the different ACSP practices that we have that require this. So I've highlighted just a few. I might have missed one or two here, but the ones that are in orange use the NRCS gully erosion tool, which is something separate from RUSLE. Again, RUSLE is only meant to calculate reductions related to reducing sheet and rill erosion. Reducing gully erosion is a different beast, and calculating the reduction of gully erosion happens through a different tool. And then some of our practices that also have a soil savings component, stream debris removal, stream restoration, stream bank and shoreline protection, those practices use a separate estimation, typically for estimating stream bank and shoreline erosion in tons per year. But the rest are typically calculated through RUSLE. Obviously, if there's some sort of gully erosion happening for any of these practices that the intervention will be correcting, then you might be using a different tool or a subsequent tool to to calculate what the total conservation effect will be. But for the most part, that's kind of how you crosswalk those practices to the tool. So with that, do you guys have any questions for the background that was presented? Great. So I'm not seeing anything. And it's 10:03. I want to be respectful of everybody's time and not go too much over. But if you guys have any other questions or need some background information about this, yeah, get in touch if we need to do any other background information about the tools. Thanks.